All right. So in the human society, what we usually see is a product that we have, right? And this product, some could be solid, some could be liquid. So let's say soap, or even engineering products, right? Could be metals, it could be anything. It could be even parts of machines, right? But then before we get this product, there are raw materials that we use in order for us to be able to convert, and then we convert these raw materials to the product that we are looking for, right? So you have the raw materials converted to product, right? But there is a part that actually does this conversion, right? So in this here is what we will have to be the what we call the a plant, right? So a plant, not the like plants like trees, right? But like kind of like a factory or an industrial building or something, right? A facility, right? That's what helps us to convert these raw materials to products, right? And then these plants are limited by some things, right? Some of them are technical, some of them are environmental, right? So on the technical aspect, you could have the design specifications. You have design specifications. You could even have the safety, right? You could have operational boundaries, a whole lot of conditions. For the environmental side, it is for the economical side, right? So lots of constraint economical side. You just have to make sure that the energy that you are using is readily available, right? And then the raw materials that you are using is also readily available. A whole lot of so these are the things that we call the constraints, right? We call the constraints, right, for the plant, right? And when we are designing this plant, what happens if when we are trying to convert this raw materials to product, we're not able to actually control it very well, or something happens, and then because we are not controlling the system, it goes in such a way that becomes ends up becoming unsafe, right? So the key word here is unsafe, right? So that's why safety is a technical term. So mainly when we talk about control systems, we are basically trying to make sure that the plant, one thing is square is safety, right? So now we introduce what we call control system, just so to make sure that we're able to produce our product, right? So we bring in a control system, right? And this control system that we are talking about has three main objectives that I want to do, right? In order for the plant to be able to convert the raw materials to the product that we are looking for, has three main objectives. First of all, is to suppress any other what do you call it, external factors, right, or disturbances, right? To suppress disturbance disturbances, right? Because when you are trying to convert this raw materials to product, there are certain things that will try to disturb what you're trying to do. So now that we've suppressed, so when the system suppress the disturbances, this is disturbances. So when we suppress the disturbances, right? Disturbances. That's one thing the control system does. So it suppresses the disturbance. Then the next thing it does is that it tries to see if it can stabilize the chemical reaction, because most of the time, so let's say here in this case you're talking about chemical reactions, right? So when you're converting the raw materials to product, you are taking it through the raw materials through a chemical reaction, right? So when we suppress the disturbances, the next thing will be for us to, what do you call it, to stabilize the chemical reaction, right? That is trying to convert the raw materials to the product, right? So stabilize the chemical reaction, right? Yeah. So when it stabilizes the chemical reaction, the next thing to do, so these are the three main objectives of a control system, right? So when it stabilizes the chemical reaction, the next thing you do is that to make sure that the output is optimized, right? So we get the best of or that we optimize the performance of the reaction, right? So that we get the product that we are looking for, right? So kind of like optimize this chemical reaction that we are talking about, right? Yeah. So these are the three main things, right? And when we are doing all this, what happens is that basically the control system is trying to achieve this when we are trying to convert the raw materials to the product, right? Yeah. So what someone will ask, what then is the control system, right? The control system is basically a setup, right? A setup that is built in such a way that you control how something or a particular system does what you want it to do. And even if there is disturbances, right, it's able to control itself to the point that it still does what you want it to do. So that's basically what the control system is about, right? That's what the control system is about. All right. So here we have basically the simulation of a part of a whole system of a plant, right? So here, what we're having here is saponification reaction of sodium hydroxide, and we have what do you call it, metal acetate, right? And then we are expecting to have these products, right? By the reaction, we have what's the name? Sodium acetate, and then we have methanol, right? Yeah. And then within this whole process, there are a lot of things that we can control in order for us to get the product that we are looking for, right? So here, for instance, we can control the, the concentration of the sodium hydroxide, can control the concentration of the this is concentration of the metal acetate, metal acetate, concentration of the metal acetate, and we can control the temperature of it, right? So within this whole system, there are some things that we can control, others we do not control, we just measure. We can measure the temperature as well. And also we can measure, sorry, we can control the flow rate of this sodium hydroxide, right? So we can control how much of this, so these are the reactants that we have here, right? These are the reactants. So we can control how much of this is flowing, control the flow rate. So to you can control the flow rate of this one, so using this, right? And even we also have pumps in order to make sure that the flow rate is constant, or to for it to flow in a particular way, right? Yeah. So this right here is just simulating a particular system, right? So for instance, let's say we want to operate this want this reaction to take place at, let's say, 76 degrees Celsius, right? And then we set the concentration that we want, right? And then if we turn on the, let's see, we turn on the stirrer within this continuously stirred tank reactor, right? Turn it on, and then now we've set the flow rate that we want for each of these reactants. Set these ones as well, and now we've turned on the pumps for them, right? So now they are flowing into the system, and the reaction is taking place, and we can see that the concentration of the products are here. So we can control a whole lot of things, can still control. So let's see, as we try to change the flow rate, things are changing within the concentration of the products are changing, right? Change the flow rate of the reactant, the concentration of the fluids are changing, right? So this is just a system simulating the whole that, right? So we are saying that it's important that we control systems like these so that we don't end up getting accident, right? So you see, even in this system here, as you can see, the volume of the reactant, or the volume of the reactants within the tank, the height is kept constant, right? And you can see that even the stirrer is moving at a particular speed, right? So a lot of things controlled, and even some are kept constant, some of them we don't control, we just measure.